m equal to minus 1 by c. So and also y1 by b square equal to 1 by, y1 by b square by minus 1 equal to minus 1 by c. Here also we get y1 by minus b square equal to minus 1 by c. So on simplifying, we get x1 is equal to minus a square m by c, and also y1 square is equal to b square by c. Minus will get cancelled. Next. So, and here Px1, we already assumed that the P is a point on the line. Since it is the point of contact, it lies on the line and also on the ellipse. So now substituting the point in the equation y equal to mx plus c. So we get y, that is b square by c equal to m into minus a square m by c plus c. On simplifying, so simplify చేసినప్పుడు we get b square by c equal to, here right side take LCM c, that is minus a square m square plus c square by c. Both sides c will get cancelled. So therefore we get here b square equal to minus a square m square plus c square. So from this we can get c square equal to a square m square plus b square. So this is the condition for a line y equal to mx plus c to be a tangent to the ellipse x square by a square plus y square by b square equal to 1. So next, let us solve some problems. Okay, here the problem is find the equation of tangent and normal to the ellipse 9x square plus 16y square equal to 144 at the end of lattice rectum in the first quadrant. Okay, so మనకి ఇక్కడ క్వశ్చన్ లో ఫైండ్ ద ఈక్వేషన్ ఆఫ్ టాంజెంట్ అండ్ నార్మల్ టు ద ఎలిప్స్ అని ఒక ఈక్వేషన్ ఇచ్చిండు, ఎలిప్స్ ఈక్వేషన్. సో ఇక్కడ పాయింట్ ఏమి ఇవ్వలేదు, దట్ ఈస్ ఇట్ ఈస్ గివింగ్ యాజ్ ద ఎండ్ ఆఫ్ ద lattice sector in first quadrant. ఫస్ట్ క్వాడ్రంట్ లో ఎలిప్స్ యొక్క ఎండ్ పాయింట్ దగ్గర, lattice sector యొక్క ఎండ్ పాయింట్ దగ్గర ఈక్వేషన్ ఆఫ్ టాంజెంట్ అండ్ నార్మల్ ఫైండ్ చేయాలి. సో ఫర్ దట్ given ellipse is 9x square plus 16y square equal 144. So by transforming the equation into the standard form, that is 9x square by 144 plus 16y square by 144 equal to 1. By simplifying, x square by 16 plus y square by 9 equal to 1. Here a square is 16 and b square equal to 9. From that a equal to 4, b equal to 3. So here the value of a and b is a is greater than b. So next, the here find the eccentricity. So that is formula for eccentricity is e equal to under root of a square minus b square by a square, which is equals to under root of 16 minus 9 by 16. So on simplifying, that is under root 7 by 16, which is equals to root 7 by 4. So next, here the point is given as the end of the lattice rectum in first quadrant. So therefore, the point of contact, that is P, is given by AE comma B square by A. So this is the end point of lattice rectum in the first quadrant. AE comma B square by A. So now simplifying this point, we get and substituting the values, that is A 4 into E, that is root 7 by 4, comma B square by A. B square is 9 by 4. So therefore 4 will get cancelled. Here the point is root 7 comma 9 by 4. So next, so at this point we have to find the equation of the tangent. So therefore the equation of the tangent is S1 equal 0. So previous one I put a discussion. The equation of the tangent at a point P on the ellipse is given by S1 equal 0. Now writing the S1 equal 0 with respect to the given ellipse equation, that is x square by 16 plus y square by 9 equal to 1. That is xx1 by 16 plus y1 by 9 equal to 1. And here the point of contact is given as, so we have, that is root 7 comma 9 by 4, by substituting x into root 7 by 16 plus y into y1, that is 9 by 4 by 9, which is equals to 1. So root 7x by 16 plus here 9 will get cancelled, y by 4 equal to 1. So by taking LCM, that is 16, we get root 7x plus 4y by 16 equal to 1. By cross multiplying, we have root 7x plus 4y equal to 16. So this is the equation of the tangent to the ellipse. And the equation of the normal, we have the formula a square x by x1 minus b square y by y1 equal to a square minus b square. So this is the formula for the normal. Now substituting the values of a square, b square, x1, y1, we get 16x by root 7 minus 9y by 9 by 4 equal to 16 minus 9. So here 16x by root 7 minus here 9 will get cancelled. That is 4 into y. Here 9 by 4 will get reciprocal. 16x by root 7 minus 4y equal to 16 minus 7, that is 7. So therefore the equation of the normal is given by 16x minus 4 root 7y equal to 7 root 7. So this is a very important problem. So next we will discuss one more problem. So that is, so see the question here. If a tangent to the ellipse x square by a square plus y square by b square equal to 1, where a greater than b, meets its major axis and minor axis at capital M and N respectively, then prove that a square by cm square plus b square by cm square equal to 1, where c is the center of the ఎలిప్స్. సో ఇది మనకి ఇచ్చిన క్వశ్చన్. సో మన క్వశ్చన్ లో ఏమి ఇచ్చారంటే the tangent to the ellipse meets the major axis and minor axis at m and n respectively. సో మన డయాగ్రామ్ చూడండి ఒకసారి. Here P is a point on the ellipse. Here Mn is the tangent. So this tangent meets the coordinate axis, that is x-axis and y-axis. Here x-axis, y-axis at m and n. సో ఈ టాంజెంట్ మనకి కోఆర్డినేట్ యాక్సిస్ ని m n దగ్గర ఇంటర్సెక్ట్ చేస్తే సో మనం రిజల్ట్ మనం ప్రూవ్ చేయాలి. సో therefore for this let p of theta, that is a cos theta comma b sin theta, be a point on the ellipse x square by a square plus y square by b square. So this is the point we are taking. This is the parametric form. So therefore the equation of the tangent at p of theta is given by x cos theta by a plus y sin theta by b equal to 1. So this is the equation of the tangent. So now transform this equation into the intercept form. So already first year straight lines law we have learned about the intercept form of a straight line, that is x by a plus y by b equal to 1. Here also we are transforming this equation into the intercept form. So we get x by a by cos theta plus y by b by sin theta equal to 1. So this is the intercept form. Here this line meets the coordinate axis or the major axis and minor axis. That means here major axis is x-axis, minor axis is y-axis. So therefore the coordinates of the point M are given by a by cos theta comma 0, and also the coordinates of n are given by 0 comma b by sin theta. సో మనకి ఇంటర్సెప్ట్ ఫామ్ లో a comma 0, this is capital A, and b 0 comma b అని చెప్పి మనకు నేర్చుకోవడం జరిగింది. Since a is a point on the x-axis, b is a point on y-axis, its coordinates are a comma 0 and coordinates of b are 0 comma b. Similarly, here the coordinates are a by cos theta comma 0 and b by sin theta. And also here observe the distance of the point M is, that is the x coordinate, that is the distance of the point M from C, that is Cm, equal to a by cos theta, and also distance of the point N from the center Cn is equal to b by sin theta. So from these two, writing cos theta, that is a by Cm, and sin theta equal to b by Cn. So now squaring and adding these two, that is a by Cm whole square plus b by Cn whole square, which is equals to cos square theta plus sin square theta, which is the identity in trigonometry. Its value is equal to 1. So therefore, here we get a square by Cm square plus b square by Cn square equal to 1. So this is the result we have proved here. So next we will discuss one more problem. Okay, next problem. Similar problem. So previous మన y equal to mx plus c అనే లైన్ tangent కావడానికి కండిషన్ find out చేసినాం కదా. So similarly here find the condition for the line lx plus my plus n equal to 0 to be a tangent to the ellipse x square by a square plus y square by b square equal to 1. So here also same method we are using. Let lx plus my plus n equal to 0 as equation 1 be a tangent at p of theta. We are taking the point p of theta as a cos theta comma b sin theta. And the equation of the tangent at p of theta is given by x cos theta by a plus y sin theta by b minus 1 equal to 0. So here it is the given tangent equation, and this is the equation of the tangent at p of theta. So here both equation 1 and 2 represent the same line. Therefore, by comparing the coefficients, we get cos theta by a. Here the coefficient of x cos theta by a, the coefficient of x here is L. Cos theta by a by L is equal to y coefficients. Y sin theta by b, sorry, sin theta by b by here m y coefficient is m equals to minus 1 by n. So from this we get cos theta by al equal to sin theta by bm, which is equals to minus 1 by n. So from these two, cos theta equal to minus al by n, sin theta equal to minus bm by n. So again, applying the identity, that is cos square theta plus sin square theta equal to 1. Cos theta, that is minus al by m whole square plus minus bm by n whole square equal to 1. On simplifying, we get a square l square by m square plus b square m square by n square equal to 1. So from this we get a square l square plus b square m square equal to n square. So this is the condition for the line L equal to Lx plus My plus N equal to 0 to be a tangent to the ellipse. So next, similarly, the second point is given as Lx plus My plus N equal to 0 to be a normal to the ellipse. సో ఇక్కడ టాంజెంట్ తో పాటు మనకు నార్మల్ కావడానికి కండిషన్ ఏమవుతుంది? Similarly, we are taking Lx plus My plus N equal to 0 be the normal at P of theta. And also we have the equation of normal at P of theta is ax by cos theta minus by sin theta equal to a square minus b square. So here also the equation 1 and 2 represents the same line. Comparing the coefficients, we get L by a cos theta equal to m by minus b by sin theta equal to minus n by a square minus b square. Here observe the coefficients here. So by equating the terms, that is L cos theta by a equal to minus n by a square minus b square minus m sin theta by b equal to minus n by a square plus b square. Here we get cos theta equal to minus an by L into a square minus b square, and also sin theta equal to bn by m into a square minus b square. Applying the values in the trigonometric identity, cos square theta plus sin square theta equal to 1 minus an by L into a square minus b square whole square plus bn by m into a square minus b square whole square. By simplifying, a square m square, sorry, a square n square by l square into a square minus b square whole square, b square n square by m square into a square minus b square whole square equal to 1. So from the numerator, we can take common n square. Here n square is common. And in the denominator, a square minus b square is common. A square minus b square whole square is common. So from this, we can write a square by l square plus b square by m square equal to a square minus b square whole square by n square. So this is the condition for the line lx plus my plus n equals 0 to be a tangent to the ellipse. Next, move on to the next problem. Okay. So here the question is, if the normal at one end of lattice rectum of the ellipse x square by a square plus y square by b square equal to 1 passes through one end of the minor axis, then show that e power 4 plus e square equal to 1, where e is the eccentricity of the ellipse. This is the question given here. Here, what is giving? The normal at one end of the lattice rectum. So for that, we are taking, let L AE comma B square by A be one end of the lattice rectum. Therefore, the equation of normal at this point is, so generally we have the equation of the normal is a square x by x1 minus b square y by y1 is equal to a square minus b square. So now substituting x1 y1 here ae comma b square by a, we get the equation of the normal is a square x by ae minus b square y by b square by a equal to a square minus b square. By simplifying, we get ax by e minus ay equal to a square minus b square. And it is given that the normal passes through one end of minor axis. So see the diagram here. Here, LL dash is the lattice rectum. At L, the normal equation, the normal is passing through the this one, passing through the end of minor axis. So this is the point, end of the minor axis. In standard form, the end of the minor axis is 0 comma minus b. So therefore, the equation passes through the end of the minor axis. The normal passes through the one end of minor axis. Here it is wrong somewhere, major axis. This is minor axis. Minor axis. That is b dash equal to minus 0 comma minus b. So substituting this point in the equation, we get into 0 by E minus A into minus B equal to A square minus B square. By simplifying, we get AB equal to A square minus B square. So now substituting the value of B square here, from the standard form, we have B square equal to A square into 1 minus A square. So, and multiplying inside, we get A square minus A square minus into minus plus A square E square. So next, here A square will get cancelled. We get AB equal to A square E square. From this, cancelling A on both sides, B equal to A E square. And E square equal to B by A. Now squaring on both sides, that is E power 4 equal to B square by A square. And again, applying B square, that is A square into 1 minus E square. Here A square will get cancelled. Therefore, E power 4 equal to 1 minus E square, which is equals to E power 4 plus E square equal to 1. So this is the result. So next we will discuss one more problem. Okay, that's all for now today. So we will discuss the remaining problem tomorrow. Here, learn these formulas. These are very important to find the equation of the normal and tangent at a given point on the ellipse.